Good evening, everyone. Welcome back to my channel. Forgive me, today I borrowed someone my mark and forgot to take it back. So yeah, just my name, but I'll get it tomorrow. Okay, it's fine. We move. Today we're gonna do grade 11 exponents. Yeah, this is the first topic and the first thing that you're gonna do when you are gonna get into your class tomorrow. So before we do anything, I want us to check the laws of exponents. You must know each and every law of exponents. You have 9 laws of exponents, but for now I just want you and me to look on the first 6 laws of exponents because they are mostly applied in the exam. Okay, so I just want us to check the first 6 laws of exponents because they are the ones that are usually there in the exam. Let me check something. Okay, they are usually there in the exam. Okay, so I want us to look at them. The last range they are quite confusing and just complicated, but now let's go to it. The first one, the first law of exponent, it is saying, as you can see, before we start, there is a base, there is an exponent. So this one is a base, this one is a what? Is an exponent. Okay, so that's what we must know. So we have the base, we have the what? We have the exponent there, a to the power of m, or this is or a power. This m is an exponent or power because sometimes you can say a to the power of m. So that's how things are. Okay, and then let's check this one. So we have a to the power of m times a to the power of n. Since it is the same basis, your answer will just have the very same base only. You are not gonna say a to the power of n plus a to the power of n. No, you simply add. So same basis, you when multiplying you add exponents. So same basis multiplying, you do what? You add exponents. Okay, let's check the example. 2 to the power of 2 times 2 to the power of 4. Wait, do we have the same basis? Yes, we do. So it is what? Same basis, you add what? Exponents, because they are multiplying. So you are just gonna write this 2 only and then say 2 plus 4, which is what? 2 to the power of 6. You see, we are done. You see, so now let's continue. Let's go to the second one. So the second one is a to the power of m divided by a to the power of n. It is equals to a to the power of m minus n. Okay, so now check. When they are multiplying, you add exponents. Okay, when they are dividing, you subtract exponents. So same basis, when they divide, you subtract exponent. So same basis, you just write this the one base there, and then these ones you subtract them. Then let's check the example. Which example can I give you? So 2 to the power of 7 divided by 2 to the power of 5 is equals to 2 to the power of 7 minus 5, which is equals to 2 to the power of 2, which can be simplified to 4. Yep. So you must know that. Okay, so let's go to the third one. The third one is what? A to the power of m close bracket times n. A to the power of m times to the power of n, or times n, or times exponent n, it is equals to am times n. So this one is the same as opening the bracket by multiplying both exponents. So here you have the base and the exponent inside the bracket and the exponent outside the bracket. So you simply multiply the exponent by saying this one times that one, which is that one. Okay, do we have the example? Okay, so 2 to the power of 3 4, which is equals to 2 to the power of 3 times 4, which can be 2 to the power of 12. But we move, you must know that. So there's another one here, the fourth one, because these things are trick. Check this one. Let's now check this one. Okay, so let's just say we have 2 bases inside one bracket. So a times b close bracket to the power of n equals to, now since there is angithi lana inside the bracket, it is a base and an exponent. Okay, so lana we have two bases in one bracket and an exponent outside the bracket, so which is gonna be what? Is gonna be a to the power of what? A to the power is gonna be a to the power of n times b to the power of n. Now they are gonna share the exponent because they are both multiplying to each other inside the bracket, and they are what? They are raised to the power of n, so they will be sharing the what? The exponent n. Okay, so now let's continue. Let me continue. Number 5, or let me just make an example for you. So let me just say I have 2 times x close bracket squared is equals to 2 to the power of 2 times x to the power of 2. Another thing that you have to know, a dot is a what? Is a multiplication sign in maths, in exponents. So that dot is a multiplication sign. Okay, we continue. Okay, and then another thing you have to know is that number 5, okay, number 5, a to the power of 0 is what? 1. Any base raised to the power of 0 is 1. Even if you can say 1 million, 1 million, as long as to the power of 0, the answer will be 1. Just know that that one is very important. You must know it. Anything to the power of 0 is 1. Then number 6, a to the power of negative m is equals to 1 over a to the power of m. You see, so now we are now dropping this thing and making it a what? A fraction. So this negative will change and it will be like this. So if it was a to the power of m, it was going to be 1 over a to the power of what? Negative 1. So the example there, it can be 2 to the power of negative 3, which will be 1 over 2 to the power of 3, or 1 over 2 can be what? To the power of negative 1. Okay, so guys, since you know the laws of exponents, let me check what I can do for you. Okay guys, before we do examples, there are some few things that I want you to know. So before you do any example or resolve any question, you must make sure you take a number to its simplest value, or you take the base to what? Simplest value. What do I mean when I say a simplest value? For example, let's just say we have 4, simple number. So 4 is a what do they call it? 4 is a perfect square. So 4 can be taken to what? To 2 to the power of 2. So how do we know, and how do we change 4 to the power of 4 to 2 to the power of 2? So you do it like this, guys. Okay, so you simply say 4, it is equals to, okay, and then you say shift, and then you see these dots here, the one on top its fact, you do like this. You see what is the answer? 2 to the power of 2. So that's how you do it, guys. You just say the number, you say equal sign, then you do shift, and you do what? Those things, and you get that thing. Okay, so this is the first thing that you must do. Make sure that you do that, because you will be stranded there at the end because you didn't change 4 to its simplest value. So be careful. Even if it is 4 to the power of x, it will be 2 to the power of 2x, because it will be 4 to the power of x, and then it will be 2 times x, which is 2x. Okay, and then another thing that you have to know, you must split. If maybe you have a combined equation, maybe let's just say maybe you have 2 to the power of 3 maybe 2 to the power of 3. Okay, let me check something for you so that I can show you how to split it. Let's just say we have 3 to the power of x plus 1. So when you want to split, you just say 3 to the power of x times 3 to the power of 1. That's how you split. And check, same basis, multiplying, you do what? You add exponents. So it's going back to the first law. So 3x plus 1, which is this one. Okay, yeah, then I'll show you the other ones when you do example question. So let me do the first example. Okay, so let's continue. let me check an example for you. Okay, so let's just say this is saying solve for x. So you just say 7 to the power of 3x plus 1, it is equals to 49 to the power of x minus 1. Okay, so how do you solve this one? Now let's check our bases. We have 7 cannot be taken to its simplest value. Let me check 49, it can be taken to its simplest value. So let me take my calculator. 49, it is equals to shift par, so it is 7 squared. So we are gonna write 7 to the power of 3x plus 1. So don't be fast, don't split immediately. Make sure what you split when you have the simplest value. So it is 7 squared, then you open bracket because there was already some exponent, so x minus 1, then it's gonna be 7 3x plus 1 is equals to 7. Then you multiply the exponents, so 2x, 2 times x is 2x, 2 times negative 1 is minus 2. So now what you have to know, if you have same basis in an equal sign, you cancel them, so you're gonna be left with the exponents. We drop them, so it's gonna be 3x plus 1 is equals to 2x minus 2. So you do your math, same like terms. So 3x minus 2x is equals to negative 2 negative 1. So since this is this and this are same like terms, 3 minus 2 is 1, so I'm gonna be left with 1 with x, and then negative 2 negative 1 is what? Negative 3. You must be fast, so that's how you do it. So if you have same basis, you cancel them and then you drop the exponents. Okay, and then yeah, I'll do my examples when I get enough time. Then let me check. So let's just do this last one. So it's gonna be 3x plus 3x times 3 to the power of 1, okay, over 8. Okay, so now I see the 3 and 8. Okay, so let me check what I can do. So before everything, oh sorry, it's plus 3 to the power of x plus 3 to the power of x plus 1 over 8. So since I have this one, I can split. So 3 to the power of x plus 3 to the power of x times 3 to the power of 1 over 8. Then if I have 3 to the power of x and 3 to the power of x multiplying another one, I check what's common. So in this numerator, what's common is 3 to the power of x. So I'm gonna say 3 to the power of x, open bracket, 3 to the power of x divided by 3 to the power of x is 1. So it's gonna be 1 plus. So this one and this one will cancel. So I'm gonna be left with 3, because 3 to the power of 1 is 3 over 8. So right now I have 3 to the power of x times 4 over 8. Okay, so what can I do there? Tell me, what can I do? What can I do? What can I do? Okay, then which means Uti, we are gonna leave it like that, because okay, so since this is 8, oh shit, 8 is a perfect square, so 8 can be taken to the power of 3. But it's fine. We will just say 2 to the power of 3, then 4 divided by 2 is what? 4 divided by 2 is what? 4 divided by 2, 4 divided by 2 is 2. So it's gonna be, so in 3 and 3 is cancelling, so x is equals to 2. Yeah, this one is, it doesn't have to have an answer, because it was just an example that I created myself. So I'm sure something went wrong, Mara. Thank you guys. I'll do more videos and more. We still have to do more things. Let me check my book. We still have to do solving for rational exponents and solving for x, whereby you have to use chi-square, whereby you have to reciprocate things. Thank you guys. Thank you.